Hello, I am Ram Mohan. I am working as head of Electronics and Communications Engineering Department placed at Mahbubnagar Government Polytechnic. The subject we are looking is the basic electrical and electronics engineering for the first years. The topic we are dealing is the resistors. In this current session, the subtopic we'll be discussing is the construction and comparing of the carbon and wire wound potentiometers. Let us see the objectives of this discussion. On the completion of this session, you'll be able to understand the construction of the potentiometers, compare the features of the carbon and wire wound potentiometers. You'll also be able to understand and compare the features of carbon and the wire wound potentiometers. Let us recap the previous sessions we have been learning. In the previous sessions we have learned about the features and the applications of the carbon composition resistors, the carbon film resistors and the wire wound resistors. Now let us see the classification of the resistors. The resistors are broadly classified into the fixed and the variable resistors. In the variable resistors, these are further divided into potentiometers and the variable resistors. Okay. Yes. The potentiometer. The name potentiometer, often abbreviated as POT, that is used when a variable potential voltage is obtained at the wiper terminal, that is a fraction of the fixed potential across the track. That means you are going to say apply voltage V across the two extreme terminals of the resistor, which is variable here, and the voltage available at the variable point, that is the figure point 2 is the terminal which is variable, that will be variable potential, and as you go on changing it you will be getting a different pickup for the current position at that place. So that is how the potentiometer is working. Now let us see the next one. The control in a variable resistor. When a wiper is connected to one end of the track, effectively making it a two-terminal device having a variable amount of resistance across the two terminals. So in the figure on the right side, you can see that there are only two terminals, 1 and 2. Here intentionally the variable terminal has been short circuited to the terminal 1. So henceforth, whatever is the resistance between the contact of the wiper and the terminal 1 will be shorted by this short circuit of variable to the 1. So that is how the value of the resistor here will be varying between 0 to V. So that is why we call this as a variable resistor. Potentiometers and the variable resistors. In the potentiometer, the resistance of the track remains the same. So the resistance is not going to vary because that is designed. So it remains the same even as the wiper is moving across the full length of the track. and only the potential that is available on the wiper that keeps on changing. Okay, yes. The next one, that is a variable resistors. So in a variable resistor, the resistance of the track apparently changes as the wiper moves and short circuits more or less of the track resistance. So this is a major functional difference between both the two. Now let us see the construction of the carbon type of potentiometer. So here you can see that there is a circular carbon track, as you can see in the figure. You have terminal 1, 2 and 3. So that is the arrow is showing you the carbon composition resistor track laid on the circular track on a high-low sheet. Yes, so that is a carbon composition resistor track, and you have a wiper in both the figures, you can see. So that will be attached to the shaft in the middle, and as you rotate the shaft, the wiper position will change. So the contact at which it is making and between the end will be the resistance at that current position. So here you can see the 1, 2 and 3 are the terminal or lugs for soldering into the circuit. Then the symbol of the potentiometer is this one at the bottom left. You can see getting highlighted. So you have terminals 3, 1, 2 and 3. So 1 and 3 are fixed terminals, the 2 is the variable terminal. Okay. Now further about carbon potentiometer. The carbon composition is used to lay the resistor track on which the wiper moves for the variable pickup point. Now let us see where we generally come across these potentiometers. So the variable resistors can be found in audio control circuits, televisions, oscillators, motion control transducers and home electrical appliances, where normally you will be having a control knob to vary the volume in radios and television receivers, sometimes to vary the brightness levels, contrast levels and color levels in a TV, of course in the older models. And in the oscillators in the lab, you will have the knob that will be fixed to the shaft of the variable resistor inside, so that will be varying the frequency of the oscillations. Then you have motion control transducers, so it's an industrial application. Similarly, some electrical appliances like dimmer circuits or heaters with control to control the temperature and likewise. So the typical applications, of course we don't have these type of TVs nowadays, but to know, most of you might have used. The potentiometers were used to control the picture brightness, contrast as well as the color response in the televisions, with CRT models, old model of course. A potentiometer was often used to adjust the vertical hold which affected the synchronization between the received pictured signal and the receiver's internal sweep circuit. So this used to be sometimes in the old model televisions, and this control of V hold they used to call was sometimes provided on the rear side of the TV. Though it's not there nowadays. Now let us see the pot components and how it is assembled. Like we are going to see the further construction of the potentiometer. So here you can see different parts that are forming into a pot. So that is a carbon track, the yellow arrow showing you that is resistance of course. Then you have a shaft, the white one, to which we will be normally attaching a knob, that is a shaft. And so this is the assembly of these three components, wherein in this picture you have this arrow is showing you the wiper. So the wiper is the variable terminal of the pot. So it makes contact continuously with the resistor track. Then this is the complete pot, fully assembled one. So an fully assembled pot will look like this one at the bottom right side of the screen. Let us further see the construction of a rotational preset. The rotational type of potentiometer or presets on the PCBs you will be used. So they are generally meant for the service control or the one-time adjustment at the production point. They are called as preset. So rotational type of potentiometer, in the figure you can see, which is called as a preset. So you have three terminals. You have the carbon black track over which you have a wiper, and you have a screw hole at the middle. With the help of a screwdriver you can vary the position of the wiper to make the required adjustment in the circuit. So this will be doing at the service or the production point. And here the tapering is possible. That means the variable of the resistance along the track can be linear or non-linear. So because this is of a carbon composition type, the tapering we call, it can be of two types, linear and non-linear, that is logarithmic generally used. And now let us see the carbon type of variable resistor potentiometer, but with a sliding model, the sliding type of potentiometer. Yes, you can see. So you have two ends at left and right, and in between there is a straight carbon track. So along with that you are able to vary a wiper. So here the tapering is possible once again because it is of carbon type. It can be linear or logarithmic. Now let us see the wire wound potentiometer. Now we are going to see the wire one potentiometer, its construction. So a typical wire one potentiometer looks like this. The yellow arrow is showing you the resistive element, so which is looking more like a cylindrical one, and the two arrows now are showing you the terminals of between at the extreme ends, first 0 and the maximum, like then they are the lux red dots, and the green arrow is showing you the variable point or the wiper terminal. Then this is the wiper that is actually attached to the shaft, and it is going to contact with the resistor element on the periphery of that. Now, this figure on the right side is the actual assembled wire one resistor potentiometer internal view. So let us see the typical alloys of continuing with the wire one potentiometers. The typical alloys that are used as the resistor wire or inside the potentiometer are alloys of copper, silver alloys, nickel chromium alloy, iron chromium alloys, and iron chromium aluminum alloys. But more commonly, people will be using the nickel chromium alloy, and usually called as nichrome wire. Let us see a wire on pot. So this wire on pot, as we have seen, so it is a assembled one inside, but so you have a shaft which is fully assembled with the resistor, wiper and all. So a completed fully assembled pot for use will look like this one, that is on your right side, fully assembled pot, and on the bottom you can see the lugs you call, or the terminals to make the connections out into the circuit. So these are some of the pots which are commonly available in the market and which are used rather. Let us see variable resistor types. Here you are able to see three different types of variable resistors. In fact, they are pots, of course. So the first one is dual gang potentiometer. So you can see the arrow, near the arrow there are two layers of carbon track with three terminals on each hilum sheet on which the carbon track is laid. Okay, so this type of actually controls were in use in the olden type of tape recorders, like where we used to have a stereo control. I'm just telling you one small example, common example. And even in industry sometimes when you want to control two channels, so there will be two concentric potentiometers, as you can see in the second figure as well. Even that is same, which is called as a concentric potentiometer. So parallelly to one shaft you will attach two wipers, and that will be rotating on the wipers. The other one is a multi-turn potentiometer. So here the angle of rotation is not limited as in the previous ones. So here it may be going up to 10 rounds in 10 rotations, and in some cases it can be 20 as well. Let's see one more. Here you can see the bottom left, which the yellow arrow is showing you, that is called as a multi-turn linear trim pot. So in instrumentation most of the time, and sometimes in some applications, so we are in need of adjustment which is very fine. So in such applications we use this multi-turn linear trim pot. So you can even rotate about 20 turns either way. So the second one is the sliding type of potentiometer. You can see that one. So you have a sliding shaft, you can move it up and down or left and right in this figure. And then the other one you have is a motorized fader. So it is nothing but a sliding type of potentiometer, and the sliding shaft is attached to a motor. So it is called as a fader or a motorized fader, rather automated one. So let us see some more type of variable resistors. As you can see, the first one is a middle one is a the red arrow showing that is a normal resistor what we have seen, and then you have a standard resistor or pot. Then you have this arrow black one showing you a preset which is open model that can be fitted into a circuit which is normally used, and in some applications we'll see these two models which the black arrow showing you. They are nothing but presets used in the industry on the PCB, but they are protected one, they are not open. So they are a better one over the previous open one type of preset. And the other one is normally what we have just now seen, a trimming pot. Let us see the symbols of the variable resistors. So here you have actually symbols for potentiometers and the variable resistors. And the potentiometers, again you have two boxes. One is showing you the symbols that are used by the European countries, and the other box is using, or it is showing you as the US standards of symbols. Well, so in the European standard, a resistor is denoted by a rectangular box with two turns at the ends, and here the arrow is showing at the middle of the resistor, which means that is a variable pot, and it is in the form of a arrow. Then in the US model you have a resistive turns sort of symbol that used to normally we use in our circuit symbolic notations. So that is a potentiometer, and the arrow now you are seeing is a preset. So the variable point is not a arrow, it is a T sort of a thing. So that means it is variable but will be fixed. So that is used to indicate a preset in the circuit diagrams. Normally the variable resistors are used for user controls. and the other ones are preset control symbols. Now let us discuss about some of the features of carbon and wire wound potentiometers. In the carbon potentiometers, the resistor materials used is carbon composition, that is a mixture of carbon powder and a resin binder. In the wire wound potentiometers, the resistive element used is a nichrome wire, that is an alloy of nickel and chromium. Further continuing features of carbon and wire wound potentiometers. The resistance value of the potentiometers carbon type is very high. It varies from 100 ohms to 25 mega ohms. The resistance value of the wire wound is very low, so you don't have much range or flexibility here. So it ranges between 0.1 ohm to 150 kilo ohms only. Now further looking at the features, the power rating of the carbon potentiometer is very low. So it is about quarter watts to 2 watts alone. And when you look at this point in the wire wound type of potentiometers, the rating is very high, and we have the range lying between 1.5 watts to 150 watts or even more actually currently. So that is where the advantage of wire wound potentiometers is. Now looking at further features, it is very easy to obtain a taper in a carbon potentiometer. So the taper, what we are referring to is the change in the resistance along the length of the carbon track or the variable point. So it is very difficult to obtain a taper in case of a wire wound potentiometers. It is really tough because you cannot increase the number of turns all of a sudden. So there are some constraints in the wire wound resistors. So other problem is the stability of the carbon potentiometer is very less, whereas the stability of the wire wound potentiometer is more due to its rugged construction. The applications of carbon and wire wound resistant potentiometers. See, the carbon potentiometer is widely used in the volume control of radio and TV receivers. The wire wound potentiometer is widely used in the voltage control in various electronic equipment as well as in some instrumentation. The applications of carbon and wire wound potentiometers continued. So the wire wound potentiometers are widely used for the various applications such as telecommunication, then audio and video equipments, your medical electronic equipments, for defense and space applications, and in telephone switching systems, of course in olden days. Again in the transducers for instrumentation, and they are also used in current and voltage balancing in some instrumentational applications and in sensing of current. So sometimes they are used as wide sensing element. Now let us compare the carbon and the wire wound potentiometers. So here you have a tabular form The first column is of course serial number. Then you take a parameter. Then we'll look at both the features in the two types of potentiometers. So first is the resistor element parameter, and the material or the method implemented in carbon type of pot is carbon composition mixture, and whereas in the wire wound it is a nichrome wire, that is an alloy of nickel and chromium. Next is the resistance value. As we have actually discussed earlier also, the carbon type of pot, they are available with high resistance values also, whereas in wire wound potentiometers we have limitation, so we don't have much, so that is low. The power rating of the carbon potentiometers is very low. As we have seen, it is very high for the wire wound resistors. Then the usage. The carbon pots are generally used in low current circuits, whereas the wire wound potentiometers are used in high current. They are used in high current applications and uses. So further comparing the parameters of both. The obtaining of taper is very easy in carbon type of potentiometers. It is very difficult to obtain such taper in the wire wound resistors. Stability. So the stability of the carbon type of potentiometer is very less, and that of wire wound is very high, that is more. And the applications is most of the time carbon pot are used in volume controllers, whereas the wire wound potentiometers are used in voltage controllers and also current controllers. And the operation of the carbon potentiometers is very silent, whereas when you look at the operation of wire wound, they become noisy. The next is the temperature coefficient of the carbon potentiometer is very high, whereas the temperature coefficient for wire wound pot is very low. So it's about 1200 ppm per degree centigrade for carbon pot, and it is 400 ppm to 20 ppm, which is very less for wire wound pots. Now let us see a small quiz. The stability of the carbon potentiometer is A low, B very low, then C high, D very high. So we know that is very low. The next one. It is easier to obtain the tapering in case of A carbon potentiometers, B wire wound potentiometers, C rheostat, and 4 none. It is carbon potentiometers. Now next one. The tapering is dash of resistance along the change of the shaft position, whether it is sliding or rotational. What is it? It is the variation of resistance. Next, the tapering is dash in brightness and other instrumentation uses of potentiometers. It is linear or non-linear. So it is referred to as brightness and instrumentation. So it is linear. We should remember that the non-linear tapering is generally a exponential model, that is logarithmic model, and that type of non-linear application is mostly used for volume controls only. So we should make a note and fix up in the mind that logarithmic means non-linear, that is in volume controls. Then normally it is frequently asked questions in the topics what you have been looking into. Write about the constructional features of a carbon potentiometer. Then draw and explain about the construction of a wire-wound potentiometer. List the differences between carbon and wire-wound potentiometers. So with that, we'll be concluding this session for ours.